There's a lot of complex math that goes into launching a rocket, but before we can even talk about rocket science, let's discuss vectors. Hey everybody, it's me, Andrew, and today we're going to be discussing vectors. But before we begin our lesson, let's review some vocabulary and some formulas that we may have forgotten from the past. So some important vocabulary that you guys should know is 1, magnitude. So magnitude is just another way of saying size. Then we have direction, which is just the path along which an object moves. A component is just a part of a larger whole. So cars have a lot of components that are all working together to make it work. And then initial is just another word for the start, and terminal is another word for end. So you should keep this in mind as we move forward. All right, so the next thing we're going to discuss is the distance formula. Now, hopefully you guys remember this from geometry, but in case you don't, let's go over it. So all this is saying is that the distance between 2 points x1, y1 and x2, y2 is going to be equal to this formula. So d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, now let's discuss what is a vector. A vector is a quantity having direction as well as magnitude, especially as determining the position of one point in space relative to another. So what's really important there is that a vector has magnitude and it has direction. Now I want us to keep that in mind as we move forward. Some vectors that are commonly used in physics are displacement, velocity, acceleration, force, and momentum. And Farhan will actually discuss that with you in greater detail, but for now, let's move on. For you to do now, I want you guys to find the distance between points A and B along the x-axis and along the y-axis. So take some time to do that now. All right, so here we have the x component, 3, and the y component, 2. So we can see that the distance between A and B along the x-axis is just 3, and the distance between A and B along the y-axis is 2. Now, if we wanted to find the actual distance between the 2 points, we would take the square of 3 and the square of 2, add them together, and then take the square root of that. So that would just be the square root of 13. Now let's discuss what magnitude actually is. And you'll notice that the magnitude of a vector v is actually just equal to the distance formula. And that's because the size of a vector is determined by the distance between its 2 points. One other thing to note is that here we'll notice that magnitude is actually represented by these 2 straight brackets, and a vector is going to be represented by some letter with an arrow as a hat. So that's how we're going to continue representing magnitude and vectors. Coming back to these 2 points, we'll notice that the distance between them is boxed and their components are circled. The x component is circled in red and the y component is circled in green. But this isn't quite a vector yet, because we don't know which direction we're going. And that's going to be determined by which point we choose as our initial point and which point we choose as our terminal point. So first, let's discuss how we're going to represent vectors. So you'll notice that vectors are going to be represented by these angled brackets. And that's how we're going to differentiate them from points or intervals. So angled brackets is what you need to keep in mind. And so for our x component, we're just going to take x2 minus x1, and for our y component, we're going to take y2 minus y1, where the initial point is x1, y1, and the terminal point is x2, y2. So now let's choose point A as our initial point and point B as our terminal point. So take a minute to write this vector in its component form. All right, so hopefully you've taken the time to write the vector in its component form. Now let's check. So the answer is -3, -2. And if you want, the work is right here, but that's how we get our answer. Now, how would our vector change when A is our terminal point and B is our initial point? Take a minute, try to solve this yourself. All right, so hopefully you've taken the time to do so. So now let's check. So we'll notice that when the direction changes, so do our signs. And that's because when we're traveling in the positive x direction, x will be positive, and when we're traveling in the positive y direction, y is going to be positive. And the same is true for the inverse. Alright, so now it's time for you guys to practice on your own. So try writing the vectors in their component forms and finding their magnitudes. So vector u will be from point A to point C, vector v will be from point B to point A, and vector w will be from point C to point B. So take a minute, solve these now. Alright, so hopefully you've taken a minute to solve this for yourself, but now let's check. So vector u is equal to -1, 4, and that's because we travel 1 unit to the left and 4 units up. And then its magnitude is going to be equal to the square root of 17. Or that's just the square root of -1 squared plus 4 squared. And then vectors v and vectors w are going to follow suit, and hopefully you got that. Alright, to finish off this lesson, here's some questions for you guys. You should send me your answers on Google Classrooms or email them to me. It's been great teaching you guys again, and I hope this really helps you with your understanding of vectors. I look forward to continuing teaching you all, and don't forget to continue watching Barso ASAP videos. Have a nice day, y'all.